Part 2. The test. The testing. I think that's a good strat. Test myself on the most recent 3 chapters and like 3 more. And then yeah, like do, or maybe that's what I do. I pick the 3 most recent and then like a reasonable portion of the rest. So like in this case it's 3 and then there's 7 left over. So I can do like an additional 2 or an additional 3 or something, and then I think I'll do wide enough. So yesterday it took me a little more. It took me like almost 2 hours to do all 10 or like 10 and a half ish chapters. So we'll do maybe chapters 5 through 10. 5, 6, 7, 8, 9, 10. So 6 chapters. Okay. We'll do some perplexity action. Got this guy open. Well, and then from yesterday, and then I'll just give it the specific shit I'm looking for each time. Another quiz, please. This time from this time 6 through 10. Okay, and we'll say through these guys. What the fuck am I waiting on? Oh, and I did most of the stuff with music yesterday too, which means that that's still okay, I think. Nice. Nice. Oh, fuck, I don't know type def yet, though. God damn. Alright, well, here's what it is. Okie dokie. Let's start with a little bit of... Wait. Oh, it's desktop audio is muted. Okay, so it wasn't music. We'll do desktop audio, and then we'll do... Does it not register there? There we go. You can probably hear it through my fucking mic. Okie doke. Something like that. And then... How late does it go? It doesn't. Okay, cool. Okie dokie. I think I'm good. 1. The result of 5 plus 3 times 2, 11. 11 because operator multiplication has higher precedence than operator plus. So it's the same. So it evaluates like 5 plus 3 times 2. Or we could say 3 times 2 plus 5. Or 5 plus that. Something like that. Cool. 2. Remainder or equality? Fuck. Probably remainder. I would guess remainder. Operator remainder. Because I don't think... Because my gut tells me that Oh yeah. Because previous tests for see if or previous is even tests using or with if num remainder 2 is 0 evaluated like num remainder 2 is 0 because they functioned properly. It wasn't num remainder 2 equals 0 because that would be num remainder 0 because 2 is not 0. And num remainder 0 is, how do I even say that? 0 doesn't, it's division by 0, which is division by 0, probably yielding an abort. We'll do it in main, test this out. In X, say 2, or well, we could just say in a if, or we could say a number though. Or do we even need one? If 5 remainder 2 is that 5 plus 2, we'll just do that. Yeah, see? Yeah, I figured. A divide by 0 error. Yeah, it looks like that's the case. We don't have main, so it's giving a linker error. Because it sees the door to main, but there isn't actually a door. There's no main. There's no definition of main. Which is what would happen if it was in here. What is the output? In X is copy initialized 5. Excuse me, we're outputting 5 and then incrementing it. And then incrementing it again. So 5, 7. Alright, well. 5, then 7 on well 5. Well, yeah. 5, then space, then 7. Because postfix operator plus evaluates to the operand first, then the side effect increments it. So 5 and operator plus as prefix first increments, then evaluates. And X was incremented twice before the prefix gets evaluated. Okie doke. The side effect of using plus plus. The side effect, so the unary operator plus plus evaluates either to the the side effect is increasing the unary operand by 1, incrementing it. Comma operator. Int X is what? I don't know. Y plus 2 and then Y is assigned this. I don't know. Does it mean that both trigger or both execute? I don't know. I have no clue. Hmm. What? So it assigns that and then it does the other actually. So it is both. Just like it's like initial or it's like defining multiple variables in the same thing. So we can just do multiple statements like that? Is that right? Really? Huh. What if I did int z is 2? I can't initialize it there. But if we're only dealing with ints, I can just say, or if we're only dealing with things that already exist, I can assign it. So I can assign multiple things. So in this case, I didn't know before testing, but after testing, commas well, operator comma associativity is left to right. So y is assigned 3. Then wait. Y. Oh. So y is assigned 3. And the return, or y is assigned 3. Then the result is discarded. Of y is discarded. Then y plus 2, so 3 plus 2 evaluates to 5 and is assigned to x. I tried initializing a variable in the within operator parentheses, but looks like we can only do compound. I don't even know what we call it. Compound operator comma things to I don't even know to split up expressions or something. I'm not sure. I mean, it's weird. Seems like operator comma is saying do the left or evaluate my left expression first, then my right. So y is assigned 3 and then evaluates to the left hand operator or operand of y, but then we don't do anything with it. Well, yeah, because we don't do anything with the left hand operand. Well, right. But don't do anything with the left result. Yeah, it's like saying just run it. Because it could have been y plus 3 and then it wouldn't have done shit. And then nothing. And then the right one. Okay, that's a funky question. Rewrite this with the conditional operator. If x is greater than 0, y is 10, otherwise it gets negative 10. So we could just say x is greater than 10. Is it? If so, y is 10. Otherwise, it's negative 10. And it is y is the whole thing here. So y is the result of this guy. Hold on. The result of this guy. And this guy's result is, if true, it's 10. If false, it's negative 10. 7. Avoid the relational operator equivalence for floating points. Because, oh, why was that with rounding errors yesterday? I think it just said correct. Because rounding errors yield unexpected results, like checking if 0.3 is 0.1 plus 0.1 plus 0.1. Seems like it's accurate for literals, but for variables like float x, or well, double x gets 0.3 if x is, or well, 0.1 plus 0.1 plus 0.1. If x is 0.3, could be false unexpectedly. Let's make this better. Unexpectedly be false. 8. Short circuit logical operator, well, evaluations are premature, or ending the conditions evaluation early. Excuse me. After evaluating the left operand for the logical, or if the left is true, it stops and evaluates to true. And for a logical and, wait, is it double or like that? Okay, it is double or. I feel like I never used conditions like this. It's just been a while. I guess it's been a while since I sat down and just made like a full, like a nice program. I mean, I'm learning a lot of funky stuff right now, like just the how things work, static casts and type conversion and error. Well, I guess the previous one was handling, so I did a lot with that, but just nothing recent. Or if a logical and, if the left is false, it evaluates to false. Because even if the right is true, it's still false. Because not all are true. Same with or, where only one must be true to eval to true. 9. Oh, fuck. Oh, fuck. Oh, no. set bit3 in this. Oh God. Okay. 8T flags. Zero, 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 zero. I think I could do 1 and then move it. So we could do, I think I could do flags or equals to assign it what's true in either. Is it this easy? 1. Fuck. I think it's like standard character output. 1. Fuck. Is it shifted this? Is it extraction? Or is it insertion? I think it's extraction. Fuck. Set bit 3. Well, bit 3 is, oh fuck. Are we saying, god damn it. 0, 1, 2, 3? Cause this is, so I saw this earlier where it was just 1 being shifted instead of the mask. But it's using a bit mask. I could have uint 8 mask 3 and it's assigned 0001 and then we say flags or equals itself or mask 3. I think that's it. So it's going to say, all right, what's similar between them? This, or which is positive only, or which is true only this guy. So it's going to return 0001. I think. I think another way could be via flags or equals 1 is shifted. Is it shifted to 3? Because I think that's what we were saying. So if we're saying bit 3, I think 3 is the last bit. So the 1's place. Well, in binary. But that means we shouldn't shift it. Does that mean, I don't know how that works. Does it mean, so we're right shifting him 3? Does that mean we have 1? And then we right shift him, which adds a 0, and we right shift him, which adds a 0, and we right shift him, which adds another 0? And I can't remember if right shifting 1 will add a 0 to the left of it, or what? I saw this yesterday, so I think so. 10. Oh, fuck. Clear? Oh, God. uint 8T flags. So it's gotta have 0, 0, 0, 0, 0, 0, 0, like that, I think. Okay. And so we say we're trying to clear this guy. 5. So we say flags and equals not is that, I don't have the not. How do I type it? Oh fuck. Shift, no. Oh, not one right shifted 5. So it makes this be 0 0 0 0 1, flips it to be 1 1 1 1 0, and sets the result to be only those that are true in both. So anything that's true besides bit 5 is going to stay true, but bit 5 is off in this one. Bit 5 is off here, so only 5 is turned off. Or uint 8t mask 5 is assigned 0 0 0 like that. 1 0 0 0. Flags and equals not mask 5. So it turns mask 5 off, so it's 1 1 1 1 0 1 1 1, and it sets it to be the things that are similar between here and him, which is stay 0, 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 now 0. Whew, that's hard. Okay. Convert this to decimal. I mean, I could do it in my brain, but in code. In my brain, that's 2 plus 8. That's 10. Because we have 1, 2, and 1. So that's the 1s, the 2s, the 4s, and the 8. And 1, 8. Could do a for loop. Or could just do, well, what would we do? We would do a for loop for each bit and check the bit's place using, by using the current or the loop variable as the bit sets index, and use .get standard bit set for, what is it? Oh, let me say, oh, is it 0b actually? I guess that's what it is. 0b 1010 dot get get index to check if we should count the 1, 2, 4, 8, 16, 32, 64, or 128. Or more if more than 8. Than size 8. Okay, so this is 0b, 0b, that, 0b, that, and then this is just used in between them. So it's 0b, that, 0b, that. Or do we do 0b, this? I don't remember. I guess not, because we're not doing it like that here. Oh, fuck, okay. Alright, I think some of it's maybe coming back. 1. Returns 1 because third index, because 0, 1, 2, 3, so 2 is third index, flipped is 1. A mask to check if bit 2 is set, uint 8t mask 2 0b 0010. Use we could do equivalency, or we could just say if what would be the code that returns it though? I don't want to do get. And I don't want to return the whole thing. I just want to return true or false on that specific one. Not sure how to return true for a specific index without standard bit set size. My bit set get index. What would we do? We would say didn't this have to do with right shifting the shit multiple times? So if we wanted to check the second one, we would right shift it twice and then say like what? If it's divisible by 2 or something? Or do we right shift it until that's the final one? I can't remember. Like what did we do? Did we like I'm thinking about stuff in my head. I'm like, do we shift it until the end and then bring it back the other way to clear both sides and yield only 1 or 0? Or doesn't it go around or something? Or no, because if it's 0 and 1 and we left shift it and then we left shift it, I'm pretty sure we lose it and we get a 0. Fuck. So do we shift it to the right until it's the last? Or do we... I feel like we shift it to the left one and then shift it to the right the rest. Do we shift the value to push off any left of it? Shift the value left until it's the leftmost value, then shift it to the right until the rightmost, then evaluate because it's either 0 or 1? I don't know. This is how I'm learning it though. Alright. Variable shadowing. Variable shadowing is when an outer variable, or when an inner variable has the same name of an outer variable that's accessible within the inner scope. Calling the identifier will call the inner variable because the compiler prioritizes the inner, prioritizes the inner scope for names. Should use the explicit namespace identifier like thing X instead of X to explicitly get the outer shadowed variable, or if global X. Oh, well, just answered that. Variable. Shadowed global variable. 16. Internal, external variables, functions with external linkage are visible to the compiler, or visible to the linker, and their definitions can be linked to calls in other files, provided the other files have prototypes for declarations to a call called thing. Internal linkage means they're invisible to the linker and are only usable within their defined file, like a static function or a const expression variable. Or a function or variable within an unnamed namespace for making things, for giving things internal linkage in bulk. Non-const global variables are harmful because could be used and could be changed anywhere they're used, and if they're global, they're usable and thus changeable everywhere, which makes hunting a changing culprit hard. Global constants could be done two ways. One, preferred, an inline const expression defined within a header file and included wherever it's needed. Inline tells the linker, tells the compiler that one definition rule isn't being broken, and for the linker to deduplicate the multi-definitions to use the one spot in memory to store the object. 2. Extern const variable defined in a .cpp file and forward declared elsewhere. Stored once in memory, but not const expression, so not guaranteed to be optimized to the full extent of the compiler. Also not guaranteed to be usable as a const expression depending on the data type. Because I think you have to be an integral type to be treated as a const expression for an integral. Or yeah, to be treated as an integral or as a const expression with only being const, you have to be an integral type. Excuse me, const bool integer, I believe, not float. Static local variables have what do we call it? Have not automatic, but is it static program lifetime, where it's created on program start and destroyed on program completion. It's given 0 or this for our standard strings. I like doing this to separate it, so it's a standard string. We'll just say it's more clear. A standard string on program start and initialized once whenever the code that initializes it is executed. 20, i.e. whenever the function is called. While loops won't execute at all if the condition is false. Do while loops will, because they execute the body once, body, then evaluate. Let's get mega concise. Do while loops execute body, then eval condition. While loops eval condition, then execute body. Do while loops must execute at least once, while loops don't have to. Because if false on first condition eval, won't execute. If you omit break in a switch and you don't continue loop's next iteration or return from the function fall through, you'll fall through to the next statement. Regardless of if another case is before it. Wait, that's 22. 21. That's 20. Oops. So this is 20. This is 21. Wait, no. This is 22. This is 21. Uh-oh. 20. 16, 17, 18, 19, 20. 21, 22, 23, 20. Oof. Inline tells the compiler that one definition rule isn't being violated and that the linker will clean up multi-definitions. It lets us define a const expression or variable or function in multiple files, usually once in a header file, which is included into other files. Either to disseminate a global const expression variable, or to optimize a function via inline expansion, which means the function must be defined in the file it's used. Goto and its accompanying statement label are discouraged because they, I don't want to say the same thing, I'm trying to make sure, they disrupt, or they cloud the clarity of execution flow. They make execution flow less clear. Resulting in spaghetti code. Int I is 0, and this does 0, 1, 2, 3, 4 through 4. It will print 0, and then it will increment this guy, which is apparently more efficient in the prefix because it doesn't really matter if it's after or before. I think the prefix was added in C++ because we always did the postfix in C. Like this. Is it better to be idiomatic? Like for int current num or int current count total count 4 while current count is less than or equal to total count current count. Oops, I fucking knew I did something stupid. The fuck is happening here? Okay, I think it was the fucking statement label there. But it was a comment, so it shouldn't do it. Never mind, I guess not. I don't know. Okay. Continue. Skips the remaining statements in the current loop. Executes the loop variable. Update code. What do you call the third part of the for loops header? The plus plus loop variable part. And skips to the next iteration of the loop. 26. Create a Mersenne twister. Seed it via standard seed sequence. Potentially initializing that with standard random device calls and standard chrono steady clock info, and call the Mersenne twister using a uniform int distribution initialized to the 10-20 range, and calling the Mersenne twister by passing it the object name. Something like uniform return uniform uniform int distribution 10-20 my twister Uniform int distribution from 10 to 20. My twister. Boom. Code coverage is the percent of statements in a unit that your test executes. Get 100% branch coverage to ensure that to account for all possible paths of execution for all possible execution flow paths. Standard character input dot clear. Assert false will abort the program at that line because the condition is false, which is like having an if condition, if statement, where if false, it calls standard abort. Static assert is to evaluate the condition at compile time, while assert is for runtime. Static assert is probably good for debugging, while assert is good for identifying cases input errors you need to handle. Runtime. 31. Mirroring conversions are when and occur when passing a non-const expression data type, or when compiler sees that a data type value, or that a data type value is that value X is it assigned, or are we talking about initialized? Well, it's a data type is being converted to another type that can't hold all values of the initial type, like converting a long double to a double, and unsigned int to an int, and int to an unsigned int, or an int to a float if the int has enough memory to have out of range values for the float. 2.5 is a double. In integers, and an int can't represent all values or all values from a double. So list initialization, list brace initialization lets the compiler detect and yield a narrowing conversion warning error. To an int. Wait, what? Int x static cast to an int y. Y 5.7 with value 5.7 explicitly converted to 5, removing the type mismatch between that result and x. Same data type. It's not an implicit conversion where we have all these common type rules. Well, in this case, there's no common type part because there's no evaluation. So that was waste. Don't know type def yet. So far, using this for namespace, or is for getting functionality from a namespace to use it as, or using a namespace identifiers as shorthand without using the namespaces, name, and the scope resolution operator. Using is also for type aliases, like using big num is long, which lets you say big num x is big ass number. Big ass number. Instead of long x, big ass number. 35. 5.5 plus 2. Usual arithmetic conversions say that integrals are numerically converted to floating point data types. So 2 int would converts to double 2.0. So sum is 7.5. Pop. And then we can do character counter. Boom, boom, boom. No, motherfucker. Copy. Paste this plain text. Fuck. Yo, 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 yo. Oh, it was showing some other stuff earlier. Okay. How do I oh, it was yesterday. How do I... What if I just did a smaller amount? So if I do here to 18 and then 19 and on. Boom. Okay, I'm gonna get water while it loads. Uh-oh. Fuck. Okay, I was doing some whack shit. What? It just says correct. It doesn't even say anything else. Oh my. Use left shift. Not right shift. We're left shifting at 3? Why? I was thinking if we left shift it, one, so I have 1, 0, 0, 0, 0, 0, 1, and I left shift it. If I left shift it 3 times, aren't I at the first index of it? For 9. If I left shift 1 3 times for a 4-bit, excuse me, unsigned in 8T, doesn't that make 1 become 1 0 0 0 instead of 0 0 0 1, which is what I want? I thought the third bit of a 4-bit integer would be this one. 0 0 0 1. So I need 1 to stay on the right side. If I shift it left, it's the leftmost one, not the rightmost. No? Simpler? The simpler. Using creates type aliases, like using vector is that. Well, type def is legacy, so like just an old way of doing it. What's templates? Simple. Okay. Yeah. What you talking about? Like a left shift. Yo, yo, yo. What? The rightmost is bit 0. If the rightmost is bit 0, and we have 0b 0101, and I want to turn off bit 0, then I just turn off 1 because I left shift it 0 times. And I have to do and not, whatever. But if I want to turn it on, if we say 0, 0, 0, 0, and I want to turn it on, and I want to turn the fourth or the third bit on, so this one, 0, 1, 2, 3, then we have to do 1 left shifted 3 times because this is 1. So we left shift them once, we left shift them twice, we left shift them again. Bit numbering. 3210. I had no idea. Gotcha. So my issue was the numbering. I.e., we could do UNAT flags, and it is 0B 0 0 0, and I could turn on and I could turn on bit 3 to make it 1000 via flags or equals 1 left shifted 3 times, because that makes 1 10, then 100, then 100, or well, that makes 1 become 10, then 100, then 100, or 100, then 1000, where 1 is in the 3rd spot, in the 3rd index, and 4 equals sets the bits in flags to be true for all that are true in either. Okay. Now I understand. Wait. Motherfucker, how do I do the damn printing though? Where's the printing? How do I do the printing to check if a certain bit is on or not without bit set? If flags and that will yield what? So if we have check bit 2, so this one, in this case it's going to be true. Flags and that. Oh, in the and evaluates to the ones that are true in both. And the flag, by definition, only has one thing that is true. So even though everything else could be true in our flags, so it could be 1111, 1110, and 1 left shifted 0 times for this index, and we could just put check index and then pass in the index number, which is 0 in this case. So left shifted 0 times, and it is checking and 1. So it's seeing 1 and 0. Nope, 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 nope. So 0, 0, 0, 0, 0, 0, 0, because it's 1 0 goes to 0, 1 0 0, 1 0 0, 1 0 0, 1 0 0, 1 0 0, 1 0 0, 0, 1. So it is false. It is off. Gotcha. So we could say include IOStream because we need standard character output to print this shit. And then we also need, well, I don't think we actually need C standard int. uint 8t. Yeah, apparently not. uint 8t flags, and it is 0b 0. Oh, so we can do that. So you have to do a number first. So we do 0 1 0 0, and then we will say if flags and 1 left shifted 2 times to check index whatever, or actually we could say void check bit set index. Oops. And then it's I'm gonna try it. So what happens if we do int index? If I put in an int, I think it's fine. Int index. We say if, oh wait, we also need to pass in the unsigned int. Index uint bit set. If bit set and one left shifted index, then output index or bit index is on. Else, or we could say return true, but I'd rather just say bit index is off. And we could just say bit index is bit index is on or off. And then we could say check bit set index flags, and we want to check index 3. But we also want to check if we shift it, if we give it an invalid one, I think it's just going to say false. Because if we left shift it again, it's going to say 1 0 0 0 0. And this one, it'll say 1 0 0 0 0 and then 0 1 0 0. And I think when it compares, it'll add a leading 0 here. I don't know. So in this case, it should be false. It's false. But if we say 2 here, it is true. That's fucking cool. Okay. In this case, we're saying, hey, this guy and this guy. The index as 2 in this case is 1, which becomes 1 0, becomes 1 0 0. Or, I mean, we could just say it's 0 0 0 0 whatever the fuck 1 becomes 0 0 1 0 becomes 0 0 0 1 0 0, which is all we care about. This guy here, bop. And bit set returns a bit set has all both true bits as 1 and others 0. So 0 and 0 is 0. 1 and 1 is 1. 0 and 0 is 0. 0 and 0 is 0. In this case, even if it was 1 1 1 1, it would still be on, and it would be 0 and 1. They're not both. 1 and 1, they are both. 0 and 1, they're not both. 0 and 1, they're not both. So no matter what, the mask is it only has 1 1. Therefore, if we say and, the most it can be is 1. The least it can be is 0. which means this guy either evaluates to 1 or 0. Well, it's either, I guess technically, we're saying it could evaluate to this. So it's either non-zero. Oh, that's the point. So it's either non-zero, and then it's converted into a Boolean here. So this could evaluate to fucking 24. So like, let's just, in this case, we'll just say standard character output. Alright, let's just do, excuse me. Well, it's going to be this and this. Does it yield an integer and then it's converted? So what happens if we just say bit set and 1 left shifted the index? Oops, hold it. Missing a parenthesis. Oh, it actually does say 4. Excuse me. Because the 2's place, 0, 1, 2, is 4. So if we said index 3, it actually says 8 because it's returning 1, 0, 0 in this case. Or 1, 0, 0. It's actually returning that. It's only when we have the logical and that it finally... Oh, and remember, this is bitwise and, not logical, not the regular logical and. Because we're returning that full value, it's only after the bitwise and, the logical bitwise and comparison, relation. Oh, no, logical. After the logical comparison, that it gets converted from 8 to be true because it is non-zero. Fan is too cold. Okay, well now I can do those now. I don't know why I said now twice, but it is what it is. Okie dokus. Oh, here we go. Yeah, let's see what we got. Cool. Multiplication precedes addition. Remainder has higher precedence. 5 and 7. Post increment versus pre increment. Modifies the operand's value as part of the expression. What is that? That's the side effect of that? Oh, okay. Yeah, it's the side effect. Okay, gotcha. Evaluates. Y is assigned 3, which is a side effect of assigning 3 to Y, but evaluates to 3 because that's what Y is, and then doesn't do anything. Then assigns Y plus 2, 5 to X. Gotcha. I never do statements like that. Some ternary action. And I guess we don't even need to make it in parentheses here. Rounding errors make exact comparisons unreliable. Stops evaluating if the result is already known. What is this question? Let's see if I can work backwards. It stops evaluating if the result is already known. You ask something and the answer is what? The fuck is that? Oh. And the result is already known due to the type of due to the result of the logical comparison. Because in this case, if the and is false first, or if something is false, if the left operand in an and logical comparison is false, then the and overall has to return false. If the left operand for an or logical comparison is true, then it must return true. So it stops because the result is already known. Say flags or equals to set it, or and equals the reverse to not. And we have to do the not part to flip all of them. That way, we are setting all of them, or that way we are because if we didn't do the or, then it would set flags to be the result of 1 and 0, or 1 and 0, which is 0. So we need to make all of the ones except the one we're comparing 1. That way, if it was already 0, then it stays 0. But if it was 1, it must stay 1. 1 0 0 0, bit flipped. It's just a binary to decimal. If flags and that. And that's checking bit 2, which is the second bit. Well, duh, but so bit 2 is 0 1 2, which is funny. It's actually the second bit in a 4-bit guy. But if it was 3, it would be the first. So you wouldn't think that 2, I mean, you would think that 2 is the second, but it's the second for the wrong reason. Local variable hides a variable in outer scope. Use the scope resolution operator. Internal is visible only in the file, and external is visible across files. Tight coupling and make debugging harder. Tight coupling? Sounds like go-to statements, right? No. Tight coupling. Wait, what? That's non-const? Well, yeah, debugging's harder. You need tight coupling. I don't know. Use inline const expression in a header to get global consts. And you could still technically do it in the other way if you did const defined somewhere and then you just for declare it elsewhere. Lifetime lasts until program termination. Inline allows multiple definitions. Do while at least runs the body once. Execution falls through to the next case if it exists. Creates unreliable spaghetti code or go-to statements. Yeah, because we have to see the go-to statement, and then we have to look for the fucking statement label, which is like go to test. And now I have to look for just test, just this one little word. It's hard to find. So it's kind of hard to find where it goes. You'd have to do like you have to step through it. And then finally hit the go to. You have to do a breakpoint at the go to and then step to get to the next part just to find out where it's fucking going to. Unless your eyes are solid enough. Or you type in go to and then look up the statement label after. Seems annoying. I think it makes sense though that loops use them because I'm pretty sure loops use go tos. So like when you do the for loop and then you finish it, it does a go to somewhere that is after the first execution. Or maybe the for loop just tracks the execution. So if you go the go to before it, it continues on from whatever the loop value is. And doesn't reinitialize it. Okay, so it's saying, yeah, I don't like having that one line because then I'm reading this and I'm thinking, okay, there's going to be code under it, but then it's just to the right of it. Continue skips the rest of the loop body for the current iteration. Yep, so we could create and seed. Well, in this case, we're not even seeding it. Fuck. We're not even seeding it? Oh, we are. We're seeding it. Yo, wait a minute. Why are we using that operator? Don't we use I haven't done it that way. I've done it the like unless I'm tripping. Yeah, like what do you? Oh, he's just initializing it a different way. Duh, I forgot you could do that. I'm used to calling the Mersenne twister with operator parentheses to get the random number. I really don't like conflating the two here, where we're saying you're initializing a random device and then calling it one time, which is going to underseed this guy, by the way. And you're initializing him using this. You're not calling him. You're not. This isn't yielding a value. You're just initializing him. And then you're creating this guy. And for some reason, you're creating him. You're creating the random device as a temporary object and then killing it. But here you're creating it and saving this guy for some reason. I'm not really sure why you would do that. You may as well just do return uniform int distribution. What the fuck? Alright, am I still tripping? Wait. Excuse me. No. Oh, it's gonna be a crazy number. Oh wait, no, because it's not gonna change because the Mersenne twister is initialized to 0 every time. So it's C the same because it's deterministic. Yeah, I don't know what you're doing int right here. Measures how much code is executed during testing. Oh, that's code coverage. Standard clear, and then ignore to remove the extra shit. Terminates the program if. Oh yeah, because ndebug turns off asserts. For compile, and it prevents the asserts from being included via a preprocessor directive. Compile time checks with your static assert. A conversion that loses data. Yeah, it's a narrowing conversion. Braced initialization prevents the narrowing, and it gives a warning at least, maybe an error. And then we can static cast from y, which is a double, to an int. Oh my god, that'll never not jump scare me. Type def is legacy, so it doesn't do templates, it only does fucking something, I don't know. 7.5. Yeah, it promotes 2 to a double, because we did 5.5 plus 2. 2 is integral. Integral gets numerically converted into, what's he called? And then bop. I think, didn't it just say promote? Wait, didn't it just say promote? Yo, yo, yo. It did not say promote, did it? Yo, yo, yo. It does not promote him. It numerically converts him to double, because that's not a promotion. Technically, it goes float double, long double, int long, long, long. So you would think, oh, int 2 double 5.5. This guy's promoted, but he's not. Promotion is within the same track, yo. A float to an int and an int to a float, those are numeric conversions, not numeric promotions. Promote is not the right word here. GG, buddy. Okay, that's it for today.